All right, let's dive right into this explainer. If you're building AI agents, you know that an AI restricted to its training data is, well, essentially just a static database, right? But an agent connected to the live web, that's a game changer. It can process real-time market trends, live documentation, breaking news. So today, we're unpacking exactly how to bridge that gap using a totally free local Python library called Scrapling, and how to do it without your token costs absolutely going through the roof. Now, you might think, hey, it's as simple as pointing an LLM at a URL to bypass that static cutoff date. Just fetch the page, send it over to the model, and boom, extract the data, right? Well, no. The reality behind this question reveals a massive financial trap, one that catches almost every developer completely off guard when they first start building autonomous agents. And here is why. Naive fetchers that just dump a single web page's messy, raw HTML straight into an LLM can run up shockingly high bills. We're talking up to 215,000 tokens for just one page. It's literally like paying to ship an entire grocery store to your house just because you needed a single gallon of milk. I mean, think about it. A typical product page has up to 150,000 characters of HTML. Multiply that by 100 pages per run, you're looking at a catastrophic drain on your budget before your agent even does a single useful thing.
So here's our roadmap for this explainer. We'll hit AI's live web problem, look at Scrapling as the self-healing solution, break down the tokenomics, explore the 3 modes of fetching, face the Cloudflare reality, and finally, touch on scraping legality.
All right, section 1, AI's live web problem. Let's look at why this clash of formats is so fundamentally broken by default.
It all comes down to who the web was actually built for. On one hand, web pages are built with unstructured visual layouts designed entirely for us, humans. But AI agents? They don't care what color a buy button is. They need that data translated into clean, structured, LLM-ready formats, like JSON arrays or CSVs, to actually process it. They just need the raw data hidden inside that layout. The harsh reality is that 85 to 95% of a standard web page is nothing but structural noise. We're talking JavaScript the model literally can't run, CSS it can't use, tracking pixels, and just dozens of nested wrapper divs. Sending all of this contextless noise to your model absolutely destroys your budget, and honestly, it degrades the LLM's ability to even find the signal in the first place. Moving on to section 2, let's talk about the self-healing solution and how we can actually adapt to the web instead of fighting it. Enter Scrapling. This is an open-source Python library, and it's already sitting at over 75,000 stars on GitHub. The absolute beauty of this tool is that it runs 100% locally and is completely free. This is a massive, massive shift away from those expensive AI scraping SaaS APIs that nickel and dime you for every single page fetch. But here's the real kicker. Scrapling isn't just a parser. It actually repairs itself. You know how traditional scrapers break the absolute second a website developer changes a CSS class or moves a div? Well, Scrapling uses what's called adaptive scraping. It stores a lightweight fingerprint of the element you want, its tags, attributes, surrounding text, the whole shebang. So, if the layout shifts tomorrow, Scrapling's local similarity algorithm kicks in, fuzzy matches the new structure, and self-heals to automatically find the closest match. No more waking up to completely broken data pipelines. Which brings us to section 3, the token economics, because efficiency is what takes this from a fun little experiment to a real production-ready tool. By leveraging Scrapling's targeted CSS and XPath selectors, you filter out all that script and style noise before it ever reaches the model. If you can isolate only the critical data, say a specific pricing table, your token bills can plummet from that 215,000 tokens we talked about earlier down to a mere 3,000 tokens. That is a staggering 95% saving per page. Just think about what that does to your runtime costs. To put that into perspective, just by doing basic HTML filtering, stripping out the massive headers and footers, you instantly cut costs by up to 70%. But when you combine that filtering with hard-coded Scrapling selectors, that's how you get to that massive 95% reduction. You are effectively swapping out thousands of tokens of messy, useless HTML markup for one tiny, clean, highly targeted JSON object. All right, section 4, the 3 fetching modes. Let's look at the technical tools in this arsenal. Now, obviously, not all web pages are built the same. Some are basic text, while others act like digital fortresses. Scrapling equips you with 3 distinct tools to handle whatever the web throws at you. First up, the standard fetcher. This uses curl_CFI under the hood for blazing fast, low-memory HTTP requests on static pages. Then you've got the DynamicFetcher, which is a Playwright-powered browser for when you absolutely have to execute client-side JavaScript. And finally, the StealthyFetcher, a hardened browser session utilizing patchwrite to spoof fingerprints and bypass complex bot protection. And there's a huge win for developers here, Scrapling's background API capture. Instead of painstakingly reverse engineering a website to figure out exactly how it loads its data, you can just pass a URL pattern directly to Scrapling. It will automatically intercept the underlying API JSON responses in the background while the page loads. It's a seriously elegant, highly efficient way to grab the raw data without ever having to deal with the visual elements at all. Moving to Section 5, let's talk about the Cloudflare reality and the ongoing anti-bot arms race. We definitely need a reality check here because, as developers, we all hate snake oil. Anyone who tells you they can bypass 100% of anti-bot systems is flat out lying. Now, while Scrapling's StealthyFetcher uses really advanced techniques to spoof fingerprints and bypass CDP leaks, when it's benchmarked against tough Cloudflare protections, it has roughly a 58% success rate. It handles basic turnstile challenges beautifully for sure, but it is not an absolute silver bullet. You still have to design your agent with timeouts and solid fallback logic so that one single blocked request doesn't crash your entire pipeline. And finally, Section 6, Scraping Legality. Let's lay down some crucial rules and guardrails. Because getting sued is a much bigger problem than a broken CSS selector. The legal landscape for scraping is shifting rapidly. Based on major cases like HiQ versus LinkedIn and Meta versus BrightData, scraping public, logged-out data is generally considered highly defensible. But listen to this. The exact moment your AI agent logs into an account or bypasses a paywall, you cross a major legal line and heavily expose yourself to direct breach of contract claims. Furthermore, personal data is never fair game, even if it's just publicly visible on a random forum or directory. European GDPR and California's CCPA strictly restrict the collection of personally identifiable information, or PII. Regulators are actively handing out heavy penalties for PII misuse in AI models. So you must run all your scraped data through anonymization tools immediately, no exceptions. To stay safe, make sure you follow this actionable checklist for every single scrape. Audit your sources. Maintain audit-ready records, and pay very special attention to Step 2, honor robots.txt. We are in the middle of a new opt-out revolution where publishers are explicitly using tags like CCBot or GBTBot to strictly block AI training and extraction. Ignoring these signals today is practically begging for legal action. So before you unleash your next autonomous agent, ask yourself this. Is your agent being fed high-value structured signal, or are you just paying for expensive, messy noise? By implementing a tool like Scrapling's adaptive engine, you can give your agents the live context they desperately need, efficiently, legally, and at a fraction of the cost. The real question is, what incredibly smart